Hello everyone, my name is Abhishek. I'm a practicing physio in the UK. I'm working as a MSK physio. This video is going to be a continuation of our biomechanics series. So till now we have been able to cover chapter 1, 2 and 3 from Levangie Norkin's. The name of the book is The Joint Structure and Function. So now, till now, until the last video, we have discussed about the structure of a vertebra, the structure of the vertebral column, the primary and the secondary curvatures of the spine, and a lot of other things as well. So now we will be talking about a bit about the intervertebral disc. Of course, all of us would be knowing that we have this cushion kind of structure which is present between two block of vertebrae, and which kind of helps to provide some cushion between the bones between two vertebrae. So we would be discussing a bit about that. So here it says it separates two vertebral bodies, hence increasing the available motion and transmits load from one vertebral body to the other. So first of all, talking about how it increases the available range of motion. So now let's say we have two solid block of bones or two vertebrae, and if there was no intervertebral disc between them. So if there were like two bones one over the other, just imagine the available motion. It's very less because there's not much scope of movement between two solid block of bones or two vertebrae. But now if we introduce a soft cushion between these two bones, the scope of mobility, the scope of movement increases. So now let's say if the top vertebra is tilting forward, the intervertebral disc, the cushion thing, will get compressed more on the front and will expand a bit more at the back, hence allowing more mobility between the bones or between the vertebrae. And that's why it says that it increases the available mobility, the available motion between two vertebrae. And the other thing is it lets the force to transmit from the superior part of the vertebral column or the cervical vertebrae all the way down to the lumbar spine. Okay, now there is one more number that we need to talk about. It says it increases 20 to 33% of the length of the vertebral column. So now the thing is, again, imagine if there were like just vertebrae one over the other, the whole length of the vertebral column would have been just this much. But now if we introduce these cushions, these intervertebral discs between the bones, hence allowing or increasing the available range of available length of the vertebral column, and hence it increases the length of the whole spine, and it increases it by 20 to 30% almost. Okay, now the thing is, the disc thickness, of course, it is supposed to increase as we go all the way down from the top of the vertebral column. So in the top section of the spine, because there's not much of force or not much of load on the top section of the spine, hence the thickness of the intervertebral disc is something around 3 mm. But as we go all the way down to the bottom section of the spine, the length, oh sorry, the thickness of the intervertebral disc increases. The reason being because there's a lot of load on the lower part of the spine. Okay, so it says that it's almost on an average about 3 mm of disc thickness in the top part or in the cervical spine, and there is almost around 9 mm of thickness of the intervertebral disc in the lower section in the lumbar part of the spine. Now coming up to the interesting part of the disc. So it says that it's the ratio between the disc thickness and the vertebral body height that determines how much amount of motion is available there in that section of the spine. So till now we discussed that we have the cervical, we have the thoracic, and then we have the lumbar spine. If I tell you the available motion, the cervical spine having the maximum amount of mobility, hence we can tilt, we can turn our neck in most of the directions because we have maximum mobility. followed by the lowermost part of the spine, the lumbar spine, and the least amount of mobility is available in the thoracic section. So in the thoracic spine, it's only a bit of forward, backward, and a bit of twisting motion that we have, not much. So now coming back to the fact that it's the ratio between the disc thickness and the vertebral body height. Let's discuss this thing. So in the numerator, in the top part of the ratio, it is supposed to be the disc thickness. So I'll put it by dt, the disc thickness in the numerator in the top part of the ratio, and the denominator is supposed to be the vertebral body height. So I'll put it vertebral body height. So mind you, it's not the whole vertebra, it's only the height of the vertebral body. As we discussed in the previous video, the vertebral body is the front section of the vertebra, and the posterior structures, we talked about the transverse processes and the spinous process and other structures as well. Okay, now how this ratio determines the availability of how much mobility or how much motion is available there between the vertebrae. So it says that greater the ratio, greater is the mobility. So if this ratio, the ratio of the disc thickness to the vertebral body height is more, it means there is more mobility available there. So if we talk about, so I have this thing over here. We can see in the cervical spine, in the cervical part of the spine, the thickness of the intervertebral disc, let's imagine it is something around 3 mm, and the height of the vertebral body is almost around 3 mm. So if we take a ratio of the disc thickness and the vertebral body height, that is 3 by 3, and that comes out to be 1. The ratio is 1. Now talking about the lumbar spine, in the lumbar spine, of course, the thickness of the vertebral body increases, something around, let's say, 9 mm. And at the same time, the thickness of the intervertebral disc also increases, something around 8 mm. So now if we take a ratio of the intervertebral disc to the vertebral body height, that is 8 by 9, which comes out to be 0.8, which is a bit less than 1. So which is a bit less than the cervical region. So that's why we say if the ratio is high, if it is 1, in the cervical spine, hence the cervical spine has got the maximum mobility. It's a bit less than the cervical spine in the lumbar spine, that is something around 0.8, and hence the mobility of the lumbar spine is a little bit less than the cervical spine. Talking about the thoracic spine, we can see, let's say if the height of the vertebral body is something around 6 mm, and the thickness of the intervertebral disc is something around 4 mm. Again, if we take the ratio 4 by 6, that comes out to be 0.6. That's the least. Hence determining that the available motion, the available mobility in the thoracic spine is the least. So it was it's a guess number. It's not exact that we get to see, but this is just an example to show you how we use this ratio to determine the amount of mobility. So it comes out that 0.6, the result of the ratio in the thoracic spine, which is the least, and hence the least mobility in the thoracic spine. A bit more, 0.8 in the lumbar spine, hence a bit more amount of mobility in the lumbar spine, and it came out to be 1 in the cervical spine, and that's why there is maximum amount of mobility in the cervical spine. And that's how the thickness of the intervertebral disc and the height of the vertebral body determines how much amount of mobility is present there. Okay, now it says one more thing, that this shows that the greater need of mobility in the cervical spine, and followed by the lumbar region, and there is more stability in the thoracic spine, which kind of makes sense. So in the cervical spine, because we need to move the neck in most of the possible directions, and hence we need maximum mobility in the cervical region, and hence this ratio is the maximum in the cervical spine, followed by the lumbar. And talking about the thoracic spine, we need more of stability and less of mobility. The reason being that we have this whole rib cage in the thoracic spine, which helps to protect all these important organs in the body. Hence, we need more of stability in that part of the vertebral column in the thoracic spine, and not much of mobility. Hence, we get the least ratio in that particular section, and hence the least mobility but the maximum stability.